Great. Now let's look at this concept as well. So in our previous video, we're looking at the domain of radical functions involving or rational functions involving radical functions. This time, we are going to look at what we call composite function. Composite function. So when we say composite of function, what do we mean by composite function? So we can say that a composite function, also known as a function of a function, a function of a function. So here we are dealing with double functions. You have one function, another function. You may have two or three or more functions. You need to apply one output onto another output. So we are saying that a composite function, also known as a function of a function, involves applying one function to the output of another function. Yes. For instance, we are saying that if you have two functions, let's say f and g, then their composite function is denoted by f oj at x is equal to f at j of x. Yes. So this is what the composite function of two functions. If you have f and g as a function, okay. So when we say composite function, we mean when you apply one function onto another function. Okay, that's where when you substitute one function into another function, depending on the kind of composite function you are asked to calculate or find. So if you further read, it says FOJ is read as J is followed by F. J is followed by F. So when you see this, you see that we have FOJ. What comes first? F comes first. And which of them is following each other? F is following what? J. Yes. So in other words, we see what? J is followed by F. Okay. And we are saying that in the case of this X, why are we saying J is followed by F? It means that for X is in the domain of J. So whatever value you get, this X you see here, it is in the domain of this function J, whereas the function J of X is also in the domain of what? F. So all the values that you get for this should be a domain of this J. This X should be a domain of the J, and the entire J of this X should also be a domain of what? F. That is what we are talking about. That is what we meant by what? Composite function. And that is what is written here. So it says for X is in the domain of J, and J of X is also in the domain of what? The function F. Great. So that is all about composite function. So composite function is very easy. It's not difficult. So whenever you are asked to find such concept, it becomes very easy. Now before that, let's look at the following properties under composite function. And these properties, there are some of them that you need to take very care of. Yes, because when questions are given to you to solve, you need to apply such property. Other than that, you are going to get everything what wrongly. So let's look at those properties. Good. So let's take them one after the other. So in property 1, we are saying that f OG, that is f following what? J, or J followed by F. This is how we write it. It means that the the domain of G of X should be in the domain of what? F. Let's move on to property 2. We are also saying we have F OG, or in bracket we have OH again. So here you have one function that is F and another function H. We have another G and another function H. So for you to find this, now you see this is what the property says. So the property states that we must first find the domain, okay, of H in J. Okay, the domain of H should be in J. After that, then the entire domain of J following H should be in what? The function F. So whatever you get here, it means that you first need to substitute the function F, the entire function H, in what? The entire function J. After whatever you get, you substitute everything in what? J. F as well. That is what this property says. Now let's look at the addition property. We can also have a subtraction property. So for the addition property, if you have it like this, it's like what we call distributive property. Remember when we're doing binary operation? Yes, binary operation, we talked about distributive what property. So this property you see here is in the form of a distributive property. So you realize that the domain of H should be in the domain of what? F. And then you sum this one up with what? The domain of H also in what? G. That's what we are saying. Okay, so this one is very key, it's very simple. And then we are saying that this is what you apply distributive property. Good. Now let's look at this. You see this one, we are saying if you see this sign, remember what we did. We already talked about inverse of what? A function. So the inverse of F is denoted by this. And we are also saying that the function itself is what? F. F is the function. And you are to what? Put the domain of this function into its inverse. So it means that you are going to put what? This property into its what? Inverse. And in that case, that is how you write it. What if you are putting the inverse into the function? And look at the property. So looking at this, you realize that this one is the same as this. Okay, when you get it in this form, how you are going to do it? You are going to do it the same way and you are going to get it. Okay, yes. But before I move to property 6, now you see, looking at this, the inverse rather what follows the function itself. So the function is followed by its inverse, and this is how we are going to calculate it. But when you come to the 5, you realize that the inverse is rather followed by its what? Function. So someone will say that if this one is written in this form, why this one is also given the same? Yes, because we are dealing with the same what? Function. This is what? A function and its inverse. So they are not different. Okay, that is why at the end of the day, if you do it this way or this way, you are going to get the same thing. But remember, if in case maybe, so let me even add this property as property 7. Let me add it as property 7. In case maybe you were given this, let's say JOF. Yes. Good. Please don't say because this and that, you realize that this one, this inverse is followed by the F, and when we were writing, we wrote the inverse first. So this one, because this inverse is also followed by the change, so when you are writing, you are going to write the inverse of F first, meaning that you are going to put g of x like this. No. Have you gotten that? The answer you get for this one, this is not the same as this. Remember, okay? Because this one we are talking about what? F. This is also F. A function and its inverse. This is F. This is also F. A function and its inverse. But this one, an inverse of a function with another what function. We are not talking about FF, they are different. So this one, how you see it, it should follow like that. So it is rather supposed to be what? So it shouldn't be equal to j and then the function, the inverse. Yes. Have you gotten the point? Good. So you see that this and that shouldn't be, they will not be the same. Okay. So don't think because you see it like this, so this, in this case, when you get something like this, you are going to write, no, this and that are not the same. They are not going to be the same. So when you are giving example like this, please write it like this. Consider this. Okay, consider this. It means you should follow. It means that the inverse of f is followed by what? J. The inverse of f is followed by j. So don't say j is followed by what? The inverse. Okay, so the inverse of f is followed by j. It's not the same as j is followed by what? The inverse of f. But if you come here, the inverse of what? F is followed by what? F is the same as when the f is followed by its inverse. Yes, so this one, when you are dealing with the same what function, then you are going to get the same answer. So that is what I want you to know, so that when you have examples like that, you don't make those mistakes. Because most students, when you teach them or you give them these properties, if you don't explain it to them well, they may make those mistakes. Okay, now let's consider the property 6. Yes, and here too, most students also make a lot of mistakes here. So for property 2, let's look at it. F OG, that's G followed by F, or inverse, or inverse. Now when you have it like this, it should be what? A reverse. You take inverse of each of them, but it should be reverse. Have you gotten that? Someone would have said that then I will take the inverse of f and take inverse of what? G, and then it should follow like that. No, but this property, when you have it like this is what you are going to write. It means that you see the G is here, but when you come here, each inverse will come first. So the inverse of G, which is last year, will rather follow what? The inverse of F. So here, the inverse of F is followed by the inverse of what? G. So take note of that. It means that I'm going to put the inverse of F into what? In the inverse of G. So the domain in the inverse of f should be in the domain of what? The inverse of G. And that is how we write it. The same way, if I had given you this, let's say we have G O F. This one should also be written as what? So this one, J comes first, F comes first. So it means here the F inverse will also start, and then the G inverse will come last. Okay, so know how to go about all these things, so that in case you get examples or questions like that, you know how to go about it. Okay, so once we are able to go through these properties, then let's take some few examples, 1 or 2 examples, and solve, so that we can end this lesson, then solve more examples in the next video that will be posted. Okay, all right, so let's take 2 or more examples on this. Okay, so in this example, we are saying if f of x is equal to 3x minus 2 and g of x is equal to x squared plus 2x, find g followed by f and then f followed by g or at what? 2. Good. So let's look at how we can do the following examples. So example A, okay, f o g, which is what? G followed by f, is written as, so you remember the properties that we give. It means that the domain of this G should be found in the domain of this f, meaning we are going to put the function of G into what? F. That is what it means. So it's very simple. Okay, so it means that wherever I see x in f, I'm going to put the entire function of g in place of f. So this one, it is going to be like, so what is my function f? This is what? 3x minus 2. So it's going to be 3, and I'm going to substitute the entire function of g of x. So this is how it is going to be. Okay, then minus what? 2. That is how it's supposed to be, so that I can write this as what? 3. And what is the entire function of g at x? That is what? X squared plus 2x. Here is minus 2. So minus 2. So we open brackets, and here becomes 3x squared. This times this gives me what? 6x minus 2. And that gives me what? My answer. All right, so you see that this is what? Very, very what? Basic. This is very, very basic. Okay, now let's look at the B part. The B part, which is f followed by g or at what? 2. So it means that here we are going to find the domain of what? 2 in what? F, and then find the domain of this in G. Okay, so this is what is going to be. It means that I'm going to put this, okay, f at 2 as the domain. So this is how it is going to be. So first of all, you need to find your f at 2. You need to find that value. Then the answer you get, you just what? Substitute. That is how we do it. So what is my f as a function? So it means wherever I see x, I will just put 2 there. Okay, all right, so it becomes 3 multiplying 2 minus 2, and this gives me what? 6 minus 2, which gives me 4. So it means that my f at 2 is equal to 4. Okay, so the 4 that I've got, I'm also going to substitute in what? G. It means that this 4 is a domain of what? F. Okay, is a domain of f at 2. Okay, and I'm also going to substitute this domain into what? G. Okay, good. So if that is the case, then let's see. Now G at f at 2 is going to be, so wherever I see my x in G, I'll put the 4 there, because we are saying we should substitute this, and we got this 4 as the image, of what? The 2. So I'm going to write so my G of at 2 now becomes 4 squared plus 2 multiplying 4, and this gives me what? 16 plus 8, which will give me 24, and that is it. Okay, so you see that this is what very basic. This is not difficult. When you are giving such example, you don't need to waste much time. Take your time, relax, and get it well. All right, good. So we shall end here and continue in our next videos. Now in our next video, we are going to solve more examples. Okay, we are going to solve more examples on this. So stay calm and wait for the second video. All right, okay. So this is Mazwiz TV. I'm your facilitator, Evans Alkine. Kindly subscribe to my YouTube channel, watch the videos. You can also send to other people so that they can have access to the videos that I'll be posting. So see you in the next video. Bye bye.